Okay, so now that we've done a couple of example problems, I have here a carbonic acid solution that's 0.5 molar, okay? And we have the two acidic protons labeled right here, okay? Here's the first Ka, here's the second Ka, okay? What is the pH of the final solution? So remember, we must first do a first equilibrium, solve for X, solve for the H3O plus from that first equilibrium, then use the answer to do our second equilibrium and solve for the final, the total, by adding the results of those together, okay? So give it a shot, see what happens, and we'll go over the answer when we get back. Ready? Good. Okay, so the answer for the question is 3.33 molar. How do we get it? Well, our first equilibrium expression, we are doing the normal plug and chug, okay? So first we have H2CO3, okay? And we know that it will lose one of those protons to become HCO3 minus and H3O plus. And at equilibrium, we have this expression. If we assume X is negligible, I don't know why I don't have numbers here. Oh well. If we assume that X is negligible, we have this expression, which gives us an X of 4.64 times 10 to the minus fourth. Okay, oh, well, there it goes. and given that our initial was 0.5, we did check our assumption, and the assumption is less than 5%, so we are okay. And we can say that the H3O plus concentration from our first equation is 4.64 times 10 to the minus fourth. Now we can move on to an icebox for our second equation. And here I have it set up, okay? So once again, we start with the final concentrations from our first equilibrium, and we set up our equilibrium constant expression by doing the change. We then move on and assume X is negligible. Solving for X, we get that. If we check our assumption, it once again is less than 5%, so that is good, and we get the H3O plus from our second equilibrium. Now that we know both equilibria, okay, we can add the total H3O plus together and get a total concentration that is basically the amount from our first equilibrium, and that gives us our pH. The take-home message for a lot of polyprotic systems is that the second equilibrium really doesn't contribute much to the overall stuff because the first equilibrium is so much more powerful. An exception to that rule is our sulfuric acid situation that we talked about earlier. So that is polyprotic acids.